Great. And we got a poll here for their experience with Unity. Cool. All right. And Warwick, how do I pronounce your last name? Molloy. Molloy. Okay. Awesome.
Let me just mute the line.
All right. It looks like we are live. Everyone is hopping in here. Aloha, everyone. Thanks for joining. This is going to be a super exciting stream. I want to make sure you guys can hear me okay. For those who don't know, hey, how's it going, Sonia, Lucas, David? Awesome. Let me know where you guys are tuning in from. We have Warwick Molloy here today. It's going to be such an exciting workshop. I'm going to introduce him and tell you guys a bit about him in just a moment. I just want to make sure everyone can hear us okay. So if you can, give me some text notifications that you guys can hear us. So awesome. I see a ton of people. By the way, guys, we totally maxed out this webinar. 738 people confirmed for this. That's insane. So awesome. Sweet. They can hear you. Sweet. Awesome. Good. Sounds good. Okay. Sweet. Awesome, guys. Cool. So this chat is going to be filling up like crazy over the next few minutes here. And obviously, we're not going to be able to see the questions that are going through this chat. So there is the QA tab. There will be a dedicated QA section with Warwick and myself at the end of this. So please, if you have a question that you definitely want us to check out, whether it's related to when should I use the C# job system, or what is Warwick's experience about, or what does he think on ECS, something I think is interesting as well is, you know, Warwick, as I'm about to tell you guys, is a part-time lecturer for Monash University, and it would be great to get his opinion on, you know, the degree and the certificates and what they mean today as a professor or as a instructor professor who is current with the technology today. All right, so we have a really cool workshop. We are covering the C# job system, and in the past, if you were in our workshops previously, we have done this twice, where we took a look at C# jobs in the burst compiler, creating iJobs, iJob parallel 4s, and then we took we did an attempt using iJob parallel 4 transforms. And the goal was, how do we get, you know, 20,000 plus game objects moving? And we could not. So I looked up an expert, found Warwick as a hidden gem on YouTube, and he has an in-depth C# lesson that really talks deeply about ECS and dots in the job system and how it works. And so I reached out to him to see if he'd be interested in doing a workshop like this. Warwick has a plethora of experience, guys. He's been doing this for 35 years, 25 years professionally, and he's adopted Unity since 2014. He is a professional software architect for Jetstar, so the crazy large airline in Australia. He is running that place, so it's pretty exciting. So we're very, very lucky to have him on this stream. I want everyone here that's tuning in, it would be an amazing help for you guys to make sure that more people learn about what Warwick is doing. So he does have his YouTube channel. We want to help him grow, and we want to collaborate with him on the future. You're going to find information related to ECS, dots, the C# job system, A-frame, which is ECS for WebGL. He covers really complex and current subjects that I have yet to see done by your traditional content creators. It also helps that he has a complete academic background, and I have to admit, guys, it's very rare when you find a professor in academia that is so current with Unity. So it's going to be really, really awesome. This is going to be recorded, and we're going to put this on YouTube as well afterwards. So if you want the recording for this, you'll get that. But without further ado, guys, I want to introduce you to Warwick. I'm going to go ahead here. We have our cameras on here. Warwick is in Australia, I believe. Right, Warwick?
That's right.
Yes, all right, awesome, good deal. And you feel free to give an introduction to yourself, and then I'll kind of take over and talk about how we're going to structure this and go forward.
Thanks, John. And it's great to be here, right? I really appreciate this. All right, so quick intro to me. So I actually started programming as a hobby when I was 10. In 95, I got my first job working in the telecommunications space, actually doing device drivers and things like that. I joined Jetstar, the airline, in 2017, around January. And I was working on Angular, actually, building out a front end and started building APIs in C# using .NET Core. I have been certified both in Java and C#. I used to program in C, C++. I've done Python. I've done a number of languages. And I've used multi-threading since about the late 90s, and actually built my own threading library actually once with a few of my mates when we finished engineering, we tried to make a game engine. So I actually built my own threading library, which was pretty nuts. So threading is something I've looked into a fair bit. I understand how you've got to deal with race conditions and how you manage threads. So when the job system came out, instead of using your own threading with mutexes in C#, actually looking at what the job system was doing and pulling it apart, but also not just the job system, but what they've done with the burst compiler, with Unity mathematics. There's some really, really awesome stuff that they've put together, actually.
Very cool. So guys, here's how we want to do this. So Warwick is a beast when it comes to C# jobs, the burst compiler, the Unity new math systems, and everything ECS and dot. So I am not. So what we want to do is, for everyone watching, everyone knows how to, how we're using Unity today, focusing on mono behaviors and things like that. So what I'm going to be doing is we are going to set up an example of how you would actually create, and what's the number that we want to work with? Do we want to work with 20,000, 30, 40? What are you comfortable with?
Me?
Yeah. What do you think we should do?
Yeah.
How many are we looking at?
Well, let's try 20,000, and then we can bump.
All right, we'll go with 20,000, work our way up. So we're going to create 20,000 game objects, and we're going to do so using the traditional mono behavior way. We're going to take a look at the profiler and the frame rate, and we'll talk about why it executes at that frame rate and what's happening underneath. And then Warwick is going to take over, and he's going to introduce you to the C# job system from his perspective of using it as an introduction almost to like the ECS framework. Is that right?
Yeah.
Awesome. Okay, so guys, we're going to go ahead here. We're going to hide this. Let me go ahead and share our screen here. And let's see, work so you can see this. This will be over here. Alrighty. So everyone should be able to see this monitor here. Let me just go ahead and here launch up Unity. Should have had that done already. Sorry, guys. Alrighty. Jobs demo. Is this a code along? This is not a code along. However, we do have, for the first time ever for you guys, a GitHub repo of some things that we're going to be doing today that we are going to give you access to. So you'll all get access to that. It will be in the descriptions once we get this uploaded and processed. Yep. All right, so give me a moment, guys. Unity is just compiling up. Again, if you guys have questions about, for example, like how... like when do I use ECS in my personal projects? One of the things that we're doing today is testing the performance of ECS in the burst compiler for 20,000 game objects. But you and I, we're probably not doing, large like simulations of assets with 40,000 objects in the scene. Most likely, I just want to know if I should use, I have a simple mobile game. Should I be using the C# job system to do simple things like rotation? Should everything be put on a multiple thread, even if it's a minor task? And that's what he knows the inner workings of, and he's going to tell us if we should be using the system day in and day out and how we should go about it. So it's going to be pretty cool.
To answer that question, yes, I think the job system should be used for as much as you can.
And there you go. And what's really cool, guys, is you're gonna see a very different way of how he structures his programs, which I believe could be our proper introduction to ECS in the future, because as Work has stated before, the C# job system is the backbone of ECS. Is that right?
Oh yeah.
So being able to structure our jobs into a component-based design is going to help us adapt to ECS in the future. So it's going to be really awesome. So here I am, guys. I'm in Unity, and all I'm going to do here, I'm just going to create our, this is going to be, for example, just a star example again. This is going to be our star manager, and we're going to create 20,000 stars in our game. All right, so typically what we would do, we're just going to create a 3D object as a cube to represent our star, and we'll just simply prefab that. All right, so you drag it into the assets, and I'm not worrying too much about the structure organization here because this is how we've done it for the past 15 years with Unity. I really want you guys to focus on what Warwick is going to do, but it's important for you guys to understand how to do this through mono behaviors so you can see why you should do it using the job system. All right, so here I have a star manager, and my star, I'm going to delete the star from the scene, and we'll create basically an empty object to be our star manager. And this guy has one job. It's going to create 20,000 stars. All right, so if we wanted to, we can provide in the inspector, we can provide a serialized value to signify, hey, how many stars do we want? So here we'll just say, hey, private int star count.
Sorry for the noise. My neighbor's car alarm's just gone off.
No worries. I don't think it's getting picked up.
Oh, good. Yeah.
Star count, we're going to say 20,000 to start. All right, and then basically once I run this execution here, all we want to do is basically just instantiate this. So we have a reference to our prefab. So we'll do a private game object, and then we'll get that star prefab in. All right, and we'll serialize that as well. So and then all we have to do now is a simple for loop, right? We're going to loop through for 20,000 times and instantiate this object. So while I is less than our star count, then we're going to say I++, and we simply just instantiate this object. All right. Now we want to scatter this across our screen so that we can have this completely populated and see what the performance is of this, and we'll also move these stars. And I see a question here that came in. What does serialized field do? Serialized field allows us to have private data members that are accessible through the inspector, so a designer can add them, but we can keep them private as a best practice. All right, so that nobody else can change the value of star count, nobody else can reassign what this star prefab means. You are going to have total control over this from a scope perspective. All right, so here's our star prefab. All right, and then here we're gonna have to define a random position. So every iteration here, we'll create a random pose. So here for the X, we'll set that to a random range of, let's say, -50 and +50. And then here for the Y, we'll do the same thing. All right, so -50 and 50. All right, and then here we can specify a vector3 pose equals a new vector3. And we're going to do the random X, the random Y, and 0 for Z. Or actually, we could even randomize the Z as well. We might as well. So here, random.range. All right, -50 and 50. Alrighty. And then here, we're going to place the pose. And then we don't care about the rotation, guys. So we're just going to do quaternion identity. So right now, right off the bat, all this is going to do is just scatter 50,000 objects. And we'll figure out how far we want the camera to be. So as soon as I run this, it will null out on us because I didn't assign this. All right, let's run that, and you'll see here that we're going to have 50,000 or 20,000 objects here. And then on our main camera, and actually that's actually pretty good for the amount of views we have in here. What's the stats of this? Right now we're at 75 frames per second, 20,000 objects. They're not all in screen, so let's go ahead here and just kind of zoom out a bit. And you'll see here, as I get more of them in view, we're dropping down to about 30 frames per second. So we're going to keep it about here at -44. The next part of this is going to be actually moving these cubes. So when it comes to movement, there's two forms to do it in mono behaviors, right? I could attach a behavior script to each star, or I could actually maintain a list of all those stars, and I could iterate through using a for loop and essentially move them that way as well, update their positions. Warwick, I'm curious if you know this from a performance perspective, having a behavior script versus having a list and iterating through, which is better?
So what, having a single behavior in one place and then using a list to drive all the objects to move them around?
Exactly.
Definitely having one mono behavior on one object, maybe an empty, and then it has a list of things that it's pushing around. That's much more performant.
All right, good deal. So you're saying basically have each star have its own behavior script of moving around randomly.
Oh, no, sorry. So I meant have that would be probably a bit less efficient if you have.
Oh, okay, yeah. Okay, you're right. We're talking about maintaining the list of 20,000 stars, right? And then iterating through.
Exactly.
Okay, good deal. So that's how we're going to do that here. So in order for this to work, I have to maintain a list of objects for every star that we create. So here we're just going to create a list, and this is going to be a list of game objects. And actually, I could just do a list of transforms here. And we're going to call these the stars, right? So, and we have to make sure we initialize this, otherwise it will be null. And once we have our list of stars, I instantiate that star here. I need to now store it in that list. So I'll create a temp variable to do that. So here, var star is going to equal the instantiate method. We're going to get back a game object. And then from here, we can say, hey, stars.add, and we'll add the star.transform. So we're now going to populate that list of 20,000 objects. From there, we'll go into our update method, and we now need to basically loop through each star and provide movement. All right. And this is where we're going to start getting into the job system, because what's going to happen here is Unity for 15 plus years has only had one core main thread, to where Everything I'm doing for my entire game is going to execute on this update loop, and it can't continue until it processes everything in this update loop. So if I have 20,000 iterations that I have to go through, my program has to wait for those 20,000 iterations to process, which is why we get these slow frame rates. And this is where the concept of the C# job system comes in. This is where multi-threaded applications come in. I don't have to halt my main thread. I can say, hey, run 5,000 objects here, run 5,000 objects here, and then when they're done, we can collectively meet up at the end. And it happens really, really fast. All right, so that's what Warwick is going to demonstrate for us. So here, to loop through this, we're simply just going to say, okay, let's go through each iteration here. So for int I equals 0, well, I is less than our stars.count for how many we have in the list, I++, and then I'm going to access that star. So here I'm just going to say, hey, I'm going to access the stars, the sub I, which is going to be 0 for the first one. And then here I just want to update the position. I'm going to say, hey, plus equals a new vector 3, and let's give it a random position. And I believe we could possibly do a Lerp here, but I think I'm just going to do, let me see what happens if we just put time.delta time in here. So it's moving just very lightly. All right. Let's go ahead here. We'll save this. And let's see what happens. So we should have these things moving around. There we go. So right now we are at 16 frames per second. And you can see here that we have set pass calls 9. We have about 47,000 batches going on, and almost 600,000 polygons going on our scene right now. So we're at about 14 frames per second. Everything's moving all over the place here. If I continue moving this camera out, you'll see it gets even lower because we're getting more of this graphics, just more renderings going on. And we're going to take a look at the optimizations when Warwick is doing his presentation. But let's check this out. So if we wanted to, if we go into our profiler now, so drop into our analysis, our profiler, you'll see here that if we look at the rendering and the scripts here, this is where most of our performance is coming from. And you'll see if we select one of these frames, and let me go into a timeline view here. You can see here that we have one update thread running right here, and it takes 8 milliseconds to process that one update thread because it has to go through 20,000 iterations. So this is where multi-threading comes in, to where I can stack these threads, and we can have as many threads as we have cores, and we can say, hey, go ahead and separate these. Put 500 on each of these cores, run them in parallel, and it's going to be insanely fast, to where in real time, if Warwick adds a bool or something like that for us to test this, you'll instantly be able to see this frame rate drop from like 8 milliseconds down to like 0.02 milliseconds. It's insanely fast. So this is how we've done it forever, this way. So what Warwick is going to do now, I'm going to let you go ahead and take over and share your screen, Warwick, and we'll observe how to approach the C# job system. I'm going to go ahead and stop talking unless I see some really good questions come up, but for the most part, go ahead and take it away.
Cool. Give me a sec. Let me just get my Unity Hub. Okay. All right. So I'll start something fresh with just to do the same thing. I'll use the universal render. Hang on, I should share my screen.
Yep. Go ahead and share your screen, and make sure it should be.
Yeah. No, you've disabled participant screen share.
Oh, there you go. Here, try now.
All right, there we go.
Cool.
Right,
and
cool.
Make sure you guys stack up your questions in the QA tab, and we'll get to them at the end.
Okay, yep. So I'm going to use the universal render pipeline. So I'll have to get rid of their example code for a sec, but there's one thing I want to keep on there, which is they have a nice little camera controller, so we can actually just practice moving that around the scene and seeing how that impacts the frame rate as well. So what I'll probably do, John, is I'll show, I'll actually just replicate what you did, but we'll do it in jobs. And then I might show some of that mini ECS project as well, just to give sort of a how to arrange things like it's ECS, or to think in ECS terms, but using the job system. While we're waiting for this to load,
Cool.
There we go, almost there. The other interesting thing about, I always get these errors, it's mostly to do with the package manager, I think, but they don't stay, which is a good thing. All right, so let me just rip out all this example stuff. Like that. Make a new scene. Don't even save. Okay. What else? I'm going to get rid of in the assets, get rid of the README. It just gets in the way. Okay. All right, that's pretty much hulled out. So the main thing I wanted to keep was, hang on, here we go, this one, the simple camera controller.
Mm-hmm.
All right, cool. So let's begin. So let me open up Visual Studio. So the C# job system is very cool because it kind of abstracts away all the complexity of dealing with threads and race conditions in memory and things like this. But it does more. It gives you, so let me just pop that there for a sec. So it gives you these new container types, native array, for instance, which lets you allocate all your memory up front. So for instance, what I like, and something I did fairly early on in my career, was get involved in a high performance web proxy, and that was multi-threaded. We're talking year 2000. And allocating the memory up front made a massive difference, because the things that impact your performance are things like a garbage collector or just allocating memory. Because if you have to allocate any memory off the heap, there's basically a central resource, being the actual heap management in the operating system. And so all the threads will compete on that. So the whole idea of just allocating memory once and then just reusing that memory makes a massive difference to performance. So because we're looking at something where you want loops to run in less than 8 milliseconds, or in the smallest time frame possible, every little thing counts in a huge, huge way. All right, so what are we going to do? So we're going to make let's have a, where are you? Get rid of that folder too. Okay, so we'll make a new folder for prefabs. Up here, we will save this thing, save the scene, and demo. In the prefab, let's make a 3D object, we'll do a cube. All right, now we'll drag that into prefabs. Delete this guy. Now we'll make a script, and this will be our star controller.
Now, do you use the terminology controller as if it was like a manager class?
Basically, yes.
Yeah, okay.
Yeah. So let's go to Visual Studio now. Yeah. Okay, so now before I get too excited, one thing I need to do is go to the package manager. I'll install the burst compiler. And this will also bring in the Unity mathematics library. And I really want to use that. So what we're going to get, instead of just a job system, which gives us multi-threading, the maths library lets you use vector instructions in the processor, which means when you're dealing with X, Y, Z, or quaternions, which are, W, X, Y, there's X, Y, Z, W, different components in the things you're manipulating, right? So X, Y, Z, for instance, with a float 3 as a position, these are really, really efficient, and it means that operations can be performed on X, Y, and Z at once in a single instruction. Remember, we want to get all the performance we can get out of the CPU. Okay, so that should be done now. So I have that installed, it's ticked. If I want the docs, I can get the docs off here, which is always kind of handy. Now, some of these docs, even though the package is listed as complete or ready for use, unfortunately, particularly the maths library, they tell you this is the function. It needs a float, float, float. They don't tell you what they do in some cases. So this needs a bit more exploration. Okay, so we've got this. We'll go back to the inspector. Okay, so let's make our, don't need those, get rid of them. using Unity dot, we will use, actually in this case, we want collections. Okay, so this will be our, the thing that kind of controls everything. So we'll need our prefab field, private game object prefab. I like to assign it null up front, and I can detect if there's if it hasn't been initialized, and I can sort of give a warning. So for instance, if prefab null debug.log warning prefab not set, for instance. You'll be surprised how often I forget. little warnings to myself are usually good. Okay, so we will also have a number of objects, serialized field, int objects, give it a number. Okay, so now this is where we want our native array. Now, because we're keeping this very simple, all we need to do is, we actually need two things. We need our positions. So a float 3 will do the job. So to have a float 3, I'm going to need a.
And Warwick, as when we were learning, taking a look at the documentation, our understanding of a native array is that it's a shared memory access point between threads. Is that right?
Yes, so it's actually a structure. It's not like a reference. So when you have a class, that's a reference.
Mm-hmm.
It's the native array is something you can access or control. Like this thing here is literally a C# API into what the C++ player code in Unity is dealing with. So it's kind of this mirrored world where the native array is actually allocated for you by the C++ code.
Okay, right. It's like almost like a function pointer, right? And like.
Yeah,
okay.
Exactly.
Yeah, if you guys are familiar with C++, it's so. But like layman's term, shared memory between the job thread and the Unity thread.
Yeah, exactly. Okay. That's exactly right. And also in the native array, let's say memory object, it's actually got a pointer, like a memory pointer. So because we have to use structures, so okay, let me take a little detour for a second. One of the nice things about C# is you've got these value types with structures, and they're super helpful because you can allocate an array of structure, value types basically, and you've allocated all your memory up front. You're not going to bash the heap later on. So it's about that efficiency. A game can take maybe 10, 20, 30, even 100 milliseconds allocating that memory up front, and then never having to deal with that again. It's the best use of time because you're basically saying, all right, let's just do that up front. No one's going to notice 100 milliseconds doing that, for the game to start up.
Right.
But it means that through the game, your updates are so much more effective and efficient. So this is my positions.
So if you can, use persistent memory.
Oh, yeah.
Okay.
Oh, yeah. I always use persistent memory. Exactly. So down here, I'll say void. Now this will be okay. Say. So I tend to break things up and give functions names, so that I'm sort of composing functions from functions. It's sort of the clean coding style. If you've ever heard of Robert Martin, he's got a book called Clean Code. Okay, so
I'm sure I have.
Yeah, it's pretty cool actually. He writes in Java, so I forgive him the use of Java, but basically, because Java and C# are quite, were similar. Mm-hmm. C# has advanced way beyond Java.
Oh yeah, I can imagine.
Yeah, I want to use this allocator. Okay, so we want the number of objects. All right, maybe I'm using the wrong constructor. Yeah, length allocator, that's what I want. Allocator dot persistent. I actually tried some of the temporary ones in previous things, and the problem with that was that they would, you run into
unloading issues, right?
Yeah,
Yeah, we
it's
ran
sort
into
of
the same.
self-disposes
Yeah,
and
exactly. Yeah.
it's mental.
Yep. So just to
Yeah.
recap, guys, what he's doing is he's taking that float value the number of objects, and he's basically saying, hey, this number of objects that we're working with as a float 3 is going to be stored and shared for the life of the program.
Exactly. And the other thing I'm doing here is I'm just getting it ready so that when the whole program's done, so this game object is going to be there for the life of the game as a manager. When the program is finished, on destroy will get called and we have to dispose of this properly. Otherwise, the system throws an exception. It gets a bit cranky. Okay, so let's see if that, okay. This means we're going to do good stuff. So here we'll do our allocate. Whoops. Okay, so, and we're good to go. Now, all right, I'm going to leave that there for half a second and we'll worry about the jobs now. So over here, let's create, okay. So this we'll start with just a move and then we can worry about how we render it to the screen as a second step, which is good for a couple of reasons. So let's just do the move star, job, without the T, job. Get rid of all that junk. We'll get rid of that junk, get rid of that junk. Public. Okay, so now use again, that never helps. Unity dot. Now for this we'll need mathematics. We'll need unity dot jobs, and we'll figure the rest out as we go. Now with the first of all, so we use the parallel job parallel 4. Control dot.
So interesting. So you're going to use iJob parallel 4, not a parallel 4 transform?
Correct. So in this case, this is just to calculate the new position.
Mm-hmm.
And so what I'll do is in the update loop, I'll actually manually go through, I'll use the update loop to basically put them. So we're going to calculate their positions first, and then I'll use the update loop to basically move them to that position.
Okay, very cool.
And then after that, we'll come back and create a second job. So I'll explain it when I get there. There's a thought process. Okay, so now this job has to have as its parameters the things that it's going to take to do the work, right? So here now we do need containers using unity.collections. Okay, so native array, float 3. So this will be the positions it's going to manipulate. Now, what I like to do is I like to actually put the thing that does the scheduling of the job, I like to put it in the job code.
Ah, interesting.
So, yeah, it's a convention I sort of arrived at, and it's really useful because it means that all of the knowledge about what kind of job it is, whether it's a parallel 4 or just an iJob, all that knowledge is in one place.
Okay, so basically everything contained within the job.
Yeah.
Okay, cool.
So it kind of keeps it more, so this is where clean code, again, the whole idea is having agility in your code. So, you don't repeat yourself, you put all the knowledge in one place, you break things up into smaller parts and, compose big things out of small things. That's the general gist. Yep, positions. This should be all we basically need. We're going to create the actual job data. Which will be this thing. We initialize it. So it'll be pretty straightforward. Yeah. So now we have to schedule it. So I'm going to return the job handle from here. Now, there's two ways you can go. I can either go job.schedule, and that implicitly uses the right class to schedule it. But I also like using the extension class directly, which seems like this. And it kind of just makes it really explicit, like I'm making a really explicit decision about what I'm doing. I just put the job here as the first thing. So you got it. It doesn't change anything in terms of performance. There's no difference.
Right. It's just how you schedule it.
Yeah, exactly. Now array length. So this will be our positions.length. Now the inner loop batch count's an interesting one. Look, 10's a great number. What's going on here is there's a bit of loop unrolling happening. So it's the way the burst compiler, it's sort of an instruction to the compiler on how to optimize some code. So when you have a large, because remember what we're scheduling here is basically a massive for loop, right?
Right.
So this massive for loop is going to go through each object, each float 3, one at a time. Now what you can do is you can tell it this batch count. So if I use 3, in fact, let's do something a bit smarter than that. Oops, not there though. Up here, const int batch size. Be 10. We'll go down here. So this has a proper name, batch size. So what'll happen is in each thread, it'll go through that batch size in a little short loop. And it can actually unroll that, or it can be optimized basically.
Oh, so interesting. Okay, so that it's determining how many iterations per thread. Is that right?
Yeah, exactly.
Interesting.
Which means then it can have less threads to schedule as well.
So how do we know how many? How can one check how many threads our cores support?
So Unity. Well, okay. So basically, if you've got the number of CPU threads that you can have, Unity will implement like a number of jobs equal to that.
Okay, gotcha. Right. And I'm sure. Okay, so we'll be actually when you run your profiler, we should be able to see that.
Yeah, exactly.
Okay, sweet.
So now this will automatically deal with itself using that begin thing. So here, what we're going to do is we're going to have our random. Now let me grab my documentation. Come here, you. Okay, so let's go to the maths library. So no, not what I want. Go back. Where are you? Math. So this thing is very, very cool. This is the library. No, it's just taking a while for the browser to load. This is the library that the burst compiler is really tuned to using this code, right? So instead of vector3, use float3, right? It's because that's all here. So you've got bools and floats. There's a whole style of programming you can do with this, which is really, really efficient, and that's called functional programming. I don't want to spend time going into that now, because that's like a whole other hour. But it just means that you can write some really, really efficient code, and the burst compiler can optimize the wazoo out of it. Okay, so what am I after? I'm after we should be in the maths, right? So you scroll down here. As you can tell, methods, that's what I want. Sometimes struggle to think and talk at the same time, or do and talk at the same time. Now down here, there should be, you can see there's a crazy number of functions available. And I'm looking for, I might be looking in the wrong spot. I am looking in the wrong spot, I think. Yeah, where are you? Give me half a second. I'm looking, there's a random function hiding here somewhere, and I just forgot where it is.
No worries. Yeah, so for you guys that don't know, basically these are these bool floats, half twos, half fours, float fours. These things are just way more optimal than your standard data types. What is it actually that makes them more optimal? Is it is it the amount of bytes they take up?
It's there's a few things. So they're all value types, so they can be copied. So value types, the benefit of value types is when you pass them into other functions, they go completely on the stack.
Right, so exactly. It's a copy, not instead of a reference.
Exactly. And so there's a couple of things going on there. It means you're not allocating any memory on the heap, so you're avoiding locking that central lock for the heap. So it's much more performant there. The other thing that's going on is with things like native array, they use these blit functions to copy really, really efficiently. So all the data that's in your structure gets copied in a really efficient way, so that basically the way the values get passed around is really super efficient, and the storage is super efficient. Then the other thing is you have, actually that was better where I was. The other thing you have is the way the burst compiler converts the operations into these parallel single instruction moldable data type of instructions. So they can manipulate all three of X, Y, and Z in a single instruction. So that's where you get more parallels.
Gotcha, right. And that's where the speed performance comes in with this guy, is that it's super efficient to use these data types.
Oh, exactly. They're damn awesome. Right, so this is what I want. Okay, so this guy will give us different types of next ball, next float 3 will be down here somewhere. Scroll this way. Which is kind of cool. So I can give a max, and basically I'm getting a single random call. Boom, I've got my position.
Oh, for float 3. Interesting.
Yeah.
Oh, it's going to give you back. Okay. Wow, that's cool.
Exactly. Now, although in this case, I just remembered, so in this case, we're going to just do delta time on each. We're going to add delta time. So actually that meant I need to add something here. So I'm just trying to replicate what you were doing before. So
Yep, no worries.
Here I want float 3. Actually, no, just a single float will be fine. I'll call this delta time. And in here, delta time equals time dot delta time. So that's all we need to do there. And I'm basically going to have a 3 delta equals new float 3. We'll just do delta time here. There's a few different ways we could do this, but it's basically going to be the same at the end of the day. So all I'm going to do now is in my positions, that's not what I wanted. Come here. Index equals, now here's a bit of fun. Index plus. So this is where the burst compiler is going to be awesome, because the X, Y, and Z components will get added in a single instruction.
Right.
Right, at the machine code level.
That's cool. Versus if you did it through a vector 3, it actually is going to process individualized.
Exactly.
That's cool.
We want the burst compiler here because I want to tell the burst compiler to burst compile it. Synchronously equals true. Okay. All right, so that should be that. Star controller. Okay, so back over here. Now what I can do actually is I'll create another class. This will be the just a util class. That junk. That junk. Should actually change my Visual Studio templates. That would be, but anyway. So I'm going to make a static class here. Now, the other thing we can do is we can actually use the burst compiler even in static methods of a static class, using burst, using unity.maths. Start with that one. So this is where we'll initialize the position. Static float 3 equals. So this is where we'll use the now. What we can do here is we can have a private read-only static. Static. I'll get there in a second. Read-only. We're going to make a random. This is the Unity. Yeah, that could be no problem there. There's a random in the Unity engine, and there's a random in Unity mathematics. So sometimes, yeah, so you can get some collision there on the name, but this should be fine. All right, so this will be our random new. Yes, it's the right one. Fantastic. Down here, I'll just say random. Oh, not what I wanted. all too often I do that far too quickly. Next, float 3. Now we could have a max, but actually, yes. No, let's do that. I know, just for fits and giggles, let's make a float 3 max. Pop that in there, which means we can set that in the Unity inspector as well. So basically, all I want to do now is return that, because that's actually the whole answer.
Very cool. So that's just going to give you a, that's just going to return to you a float 3 that's completely random.
Yeah.
At like crazy fast times, like crazy fast execution time.
This can, exactly. This will be pretty performant. So again, we'll make this burst compile.
Oh, that's interesting. So you have to mark methods that you want to use the burst compiler as burst compile?
Yeah.
Okay, good to know.
So yeah, you have to give the burst compiler a bit of a hint. Synchronously equals true. There's a subtle difference on whether, if you don't have the compile synchronously, it'll do it sort of asynchronously. So it's, I'm shooting for the idea of having it done up front and kind of bearing that cost once of compilation. Now, because this is practically, like, it's such a short thing, I also like the, you know, in C# they have the expression method body style.
Yeah. That's like a new C# 6 feature, I believe. Yep.
Yeah, C# 6 or 7, yeah. So there we go. And the brevity of that is just fantastic. Now, okay, so down here so we'll do here, no, wrong one, start control is what I want. So here we've got our onDestroy, our allocate. We'll make a, it's just going to initialize the values. Right. Set all positions. Okay, so now we're just going to use a regular for loop here. We could try doing this and seeing if we can burst compile this later, but anyway, that's just a thought. Index equals 0, positions dot length plus. We're basically going to do our positions dot this way equals util dot make pos. And now let's come back to that one. Remembering just now that we should have our field. Now we need to add. No, I've got it there. Right, so we have float 3. This will be our max range. Basically, initialize it with something useful. 50. In John's example. Yep, that's good. Okay, right. So now here we have our range. Okay, why are we upset? No, good. Okay, just took a while. Alrighty. So that is that. We can do now. We can do set positions. So we should be good to go there. And then the next thing is to call the job on a regular basis. Okay, so now I need to also remember the job handle. Call this move job. Down here, let's see. We'll keep that there. So if move job dot is completed. So what I want to do here is I'm kind of allowing the idea that the positions will be adapted in the background. So I'm sort of keeping a separation between the main thread, which renders the scene or triggers rendering, and the actual, you know, the generation of the new positions. So I'm keeping them separate. So I'm trying to maximize the separation. So here I'm just saying, well, if the job happens to be done, let's use those positions. And if it's not done, we're going to leave them alone. Now, the interesting thing with the job system is that even though it's told us it is completed, we've confirmed through an if I still need to tell it to complete. And that's actually about the move job. The handle is more than just a signal that the job is done. It's also a lock.
Oh, right. That's right. It unlocks those threads so you can add new data to them to process.
Exactly. Because
Gotcha.
if I don't do that, then I can't access the native array.
Gotcha.
position.
Right. That's correct.
So it's that's an interesting bag of fun, that one. So move dot begin. Hang on, what did I not do? Public. Static would be good.
For your position array, actually, I'm sorry, not for your position array. Can you go back to your job for a sec? What's the value in adding read-only to delta time there? For example, like a read-only attribute.
Yes. So that's a great question. So in fact, I should do it. So the thing about the read-only, it's a signal to the burst compiler about where semaphores or mutexes need to be locked, like what things it has to worry about, and whether it has to check that it has access before it manipulates both either read or write. And so the read-only or write-only is telling the burst compiler, it's giving it more information on how to manage locks. And it means it can optimize away certain things. So if you've got jobs running in parallel or as dependencies even, by flagging that correctly, you can eke out just a little bit more performance.
Okay, very cool. Good deal.
Yeah, for instance, I should make this read-only. So this is a signal only for the burst compiler, and it only applies here, because obviously here we're writing to it as we set things up.
Very cool.
This guy, on the other hand, is read and write, so I'm just going to leave it alone.
Yeah, yep.
Because we have to read its current value and add something to it.
And then your constant, doesn't matter if you add it to a constant or no?
Yeah, exactly. No, the constant's just, that's out of bounds.
It's read only anyways. Yeah, okay. It's like defaulted. Gotcha.
Yeah, exactly.
Gotcha. Yeah, for those who are wondering, I saw a few questions go by. The constant is a promise that this value is never going to change.
And it's enforced by the C# compiler as well.
Yeah.
It won't even let me. Okay, so this should be good to go. All right, so let's go back to here. You can see the burst compiler is already compiling. Now I need to create an empty. This will be our controller. Oh, something else I like to do is up here. I just hate having to go through lists and lists of things to find it. So demo, we'll just do this / So that just means, go back. That just means when I go here and I go add component, I can find demo star controller.
Ah, that's cool. I did not even know you could do that. Everyone else a little mind blown by that trick. That was cool.
No, not presets, prefabs. Okay, so I'm going to drag that into there. So we've initialized that. We've got 20,000. Let's cross our fingers and see what happens. Okay, there we go. Kaboom. That's fine. So what do we do? I messed something up here. Writes to the native control.
Looks like it needs a dependency.
I'm trying to schedule writes. Okay, so first of all, actually, we should have seen nothing move at all. I know it. Okay, you know what it is? This update is starting before the set all positions is done, because that's the only competition that can happen.
Okay, so it's just create a flag, yeah?
Yeah. Yeah, we can. Let's try that. Yeah, exactly. That should work, actually. So bool is initialized false down here in settle positions. Initialized if it's true. The other thing we could have done is we could have moved the settle positions thing into its own job, but that would have been a bit more effort than worth it. So is initialized and move job is completed. That should solve that. Now, again, we've got all this computation going on behind the scenes, but we're not actually moving them, so they should not move yet. But we should, okay, this is what's going on here. Random object has not been, yeah, okay, fine. Util.
Someone asked about where you're setting the data. It's important to know that he has his data being set in the constructor of his smooth star job. So he's assigning time.delta time in the constructor as well as in the constructor as well as his random access. I'm sorry, not his random access, his shared memory, his native array.
Yep. Constructors. You went 32. Yeah, that's fine. So we just needed a seed value. That's what I was moaning about there. Oh no. Okay. Fine.
It's fine. I tell people all the time, like, people don't realize that 99% of working in the real world is this. It's debugging. This is more valuable than going through the debugging process than having it work perfectly, because when you attempt it yourself and shit hits the fan, you don't know what to do.
Exactly. Alrighty, we got past the initialization. What's going on here now? Scheduled job. What? It's like you lie. What's going on? Previous scheduled job. Yes. Right to the native array. Yes. Okay. Okay. I know what the problem is. It's moaning about this. So it looks like it's competing against itself, which is kind of bizarre. But in worst case scenarios, we end up having to create two of them, one as the previous value and the other one as the next value. That would be annoying. I don't think we have to do that. Let's say, I'll just call this temp equals, I'll just do that.
Oh, that's interesting. Yeah, okay. It's because you were accessing the array itself. It's in the process of executing. You can't do that. Yeah. So you had to use a temp and then assign it back into the array. That makes sense.
It's not that.
But yeah, it's sad that it wasn't that, but that does make sense that it would be upset with you doing that.
Yeah, exactly. All right, so it's basically competing against itself, which is a bit of fun. Okay, so there's a few things we could do here. I can go and create basically one native array that I'm going to read from, and another native array that I'm going to write into, which is tedious but quite doable. The other thing we could do is we could get rid of the iJob parallel for and just make it an iJob, and I think that'd work. And it'll be an interesting exercise just to see if that will work.
So what's the difference between an iJob and iJob parallel? Like, can I still an iJob would still run multi-threads, right? Like, it's just not designed to be an indexer? It'll basically create one. It should only create one thread. So it'll be a background thread. The difference is it's not going to try to, so like with the iJob parallel for, it's basically doing a for loop, but that's scattered across a bunch of threads. I got you. Right.
Yeah. And I think what it's complaining about is that the data structure, because the way the lock works, it works on the entire native array. So what's going on is we're competing against other threads because it's spread out the for loop across all these different threads. They're now competing against each other to lock the one native array, which is why if instead I make two native arrays, make one read only and the other one write only, then it should be a bit smarter about it. That should work.
Right.
But let's just try this first, because we may find the performance will be good enough without having to go to the next level. That was too much. That one. And this guy doesn't need an index anymore, but I'll take that out. Now I'll make a for loop here. 4, bang, 0. This is one of the reasons why, okay, yeah, you don't need the length anymore. You need the batch size. Just that. This is why having the begin is handy, because you can just change the structure and the rest of the code doesn't care. Got too far. Oh, not again. I did that before. Index. So all of this should now run in a background thread. That we don't need anymore, but I'll leave it there just in case. Yeah, okay. So let's see now if we get past this mess. Go away. Try again. So all right, that's interesting.
This looks like it's upset about job handle complete.
It is. Wait, what? Hang on. It's telling me before I deallocate the native array safely, but I think there are two problems. Probably. Hang on. I shouldn't be allocating that thing in a loop. What's it on about? So now let's just have a loop at that error again. So I'm about deallocating. Check deallocate row. Yeah, dot positions. Oh wait. Why are you deallocating that?
Does it matter that you have a static reference to this begin method in here? Does this have to be static?
Oh no, that has to be static. That has to be static.
It does.
Oh yeah, and that should work. It's deallocating this, and that's what at least that's what it's saying. Writes to, yes, I know it writes to that. You must call on the, yes, before you deallocate them.
Did you set the allocator type to be persistent?
So the place where this makes sense, the error is correct here, but only here. So for instance, what I should do, so with the positions array, because this is where the whole program is going to terminate, but we should have only sent an error right at the end, not like all the time. So that's kind of funny. I was actually going to leave that there and we would tackle it later when it kind of forced me to. So I don't think it's this. And I'm kind of, in fact, just to make sure, because this is the only place where it really is being deallocated.
Right.
So let's comment that out just to make sure that isn't the problem, but it shouldn't be. Yeah, that's on destroy.
Does that have anything to do with calling on line 35, you're completing the job before you've ever executed it?
No, that's fine. So the thing is the move job, its default value is in completed state. So it should actually pass through this and then calling complete on it. If it's already complete, it just goes, yeah, or whatever.
Gotcha.
So that's why that's a nice, neat little way of handling jobs actually, as a pattern, job handles. Okay, there is a couple of things. We haven't actually created the objects, which is a bit of a thing. I don't think. Set all positions. Got to make my positions here. So I can create my instances, but again, that's not a big issue. That's pretty straightforward stuff. Positions is set up. Why are you moaning? All right, just to be silly for a second. When you're faced against problems that shouldn't happen, cut code out, break it down, find where the problem is. So let's have a look. This should run blissfully with one error. The one error should be when I stop it. Yeah, see, this is fine. So when I stop it now, it should moan about not disposing. Oh, it didn't even do that.
I think you commented out. Well, yeah, it's not disposed, but yeah. That's weird.
It should have been allocated though.
You want to add a log in those? Add a log into your undestroy too.
Yeah, that's a good point.
Yeah, we haven't had when we were going through this, we were having a lot of issues telling us that we were accessing memory again before disposing of it, but we were also using temp allocators, not persistent.
Yeah. Yeah, those things become a bit tricky in that way. For a couple of reasons, they become a bit tricky.
Oh, you know what, too? Someone just mentioned this, although this shouldn't matter because you're creating a float 3 array out of this. We're not dealing with any game objects at the moment yet, right?
Correct.
Yeah, you're not doing anything with the prefabs yet.
Yep. No, so we will do that because without them, there's nothing to see. So
right,
we need them.
Yeah, we're just doing all the execution underneath.
Yeah, we're just getting kind of the memory management stuff sorted.
So, and you could check. Let's see what happens if your Destroy gets set up here.
Yeah. Huh. That is quite surprising.
You know what you could do too? You could probably on the Destroy, you could probably have it complete a job if it's upset about completing before destroying.
Oh no, that's true. I was actually, yeah, I'm still quite surprised. Just because we've created the positions, this thing, usually it gets a bit cranky. I know why it's not getting cranky, because I haven't started a job yet. So when the program ends, basically it's going to dispose of it automatically.
Right.
And if there's a thread running in the background, that's why it will complain. Because we haven't even started one yet, it's not complaining because there's nothing.
Yeah, that makes sense. Right. Update got it. Yeah, right.
Yeah. So that's why that's not yet happening, but that's fine. Okay, so all right, we know that we've allocated our things. Let's bring this back. One bit at a time. So, okay. This should make it cry out again, but native collection. Yeah, that's what I was expecting before. It just took a while to show, I guess. All right, interesting. That's what I was expecting before about this undestroy. So that's why we need to dispose of it. Now, the fact that we're disposing of it, let's move this comment ahead. When we have jobs running, that dispose will run in competition with the job, so it should complain about that. We can fix that by saying...
let me see. Someone's saying they see... Daniel, you found the solution? What was it? Daniel is saying for the newest job, then you check it as move job is completed, else you never get the latest job handle. Something related to his message is broken up. Daniel, if you want to write it out in one sentence.
Thank you.
Oh, right, you're returning something, right? There you go.
Yeah.
Nice. Oh, there you go. Right, we never assigned it to your move. There you go, Daniel. Good job.
That would be it. That would be the problem. So this control was completely ineffective because we weren't doing that.
Right, it was getting returned into like oblivion essentially.
Exactly.
Nothing was going to happen yet.
Flush down the toilet.
Yep. All right, fix that.
That'll be it. Now I should still, when I stop, I should get one complaint. So this is running. It's doing stuff in the background. And you may not believe me, but we can bring up the profiler and we can see. Actually, yes. Okay, so the C# code is running quite efficiently.
Yeah, look at that. I got 10,000 FPS. But that's just the code. There's no rendering down.
Yeah, there's no rendering. That's why it's so fast. But if we look at render loop, yeah, we can basically, here we go, this guy. Behavior update, star controller, it's taking hardly any time at all. You can see, what I like about this actually is if you click on different things, you can see a highlight of what it impacts up here. So as I click on this tiny little blue line, that's how much CPU, 0.01 milliseconds.
Right, look at that. It's
taking
insane.
Nothing of nothing.
So it's right now, every frame calculating 20,000 new positions, right?
Yeah.
Okay, good deal.
I'm just doing nothing with them, but yeah. So, all right, so now we need to, and now we should see it moan. No, not going to moan yet. Wow, that's taking a while. Oh, I know why. Right, so it's got a funny thing in the editor. Part of the player code is still running in the editor. The editor is both player and editor. So the native array is kind of still in memory. And so it'll take a little while for Unity to kind of go, oh, no one's using that native array anymore, and it'll clean it up. And that's where we start getting funny error messages. But I'll do in fact, the other reason why is because I did this.
Yeah, it forced it to complete before shutting off.
Exactly. Now the funny part is the complete here, it grabs a lock, but it has to wait on the lock. So this can take a little while. And there's actually a bit of code that I quite often do to force all the jobs to have executed, because sometimes jobs can linger and they won't complete. So if I do job handler dot schedule batch jobs, this forces them all to run, just in case there's anything lingering, so that you can unlock. Otherwise, you kind of get into a deadlock state. So this forces it all to be batched. Then we can complete, and then we can dispose, and everybody's happy. Okay, so now let's make some game objects. So down here, we'll make.
All right, now for what everyone has been waiting for.
Yeah, exactly. Actually moving stuff. Okay, so down here, we're going to do a for loop.
I really do like how you contain everything within the job, including the creation and the scheduling of it. That makes it to where you can keep all that thread logic to itself, and your update loop can stay independent of it. It's a really cool way to do that.
Yeah, it really helps just keep everything self-contained and clean. Yeah, it took a few iterations to discover that one, let's say. Okay, so now what we're going to do here is we're going to do was this one, instantiate. I've learned through painful experience that it's good to be clear about what you want to instantiate, because you can also instantiate components. So I was like, okay, the game object I want to instantiate, and things get a little bit clearer. Now we want the prefab. I had some crazy. Yeah, we want position, so it'll be position. Yo, come back, index, and then quaternion, the identity. So we're just going to put it in the position. Now, yes, we've made our position before when we set them up. So they have a useful position to start with, but with no rotation on them. That should be good to go. Yep. Actually, the funny thing is we don't really need this variable at all. I could do that because we're just going to create them, and actually that's not true. At some point later on, that will become useful. So I'll leave that alone. We will use that later. Now, right. Create game objects. Let that compile. Okie dokie. Clear that up. Hit run, and we should actually see stuff. Now they shouldn't move yet, but they should just. There should have been more positions than that, but okay. Are they all in one spot? They sure are. Okie dokie.
So that could be because I believe you were getting float threes based on time.delta time, so they're so tinily spaced apart. Is that possible?
Actually, let's go back to that. They should be. They should have been random. Like with the randomize function should have made them, but within the range of
but like, yeah, is it a random range between like 0.2, 0.20, like 0.02, 0.02?
Could be. Yeah, it could be. It could be.
So give it like a multiplied modifier, maybe.
I might have to. Yeah, exactly. So let's have a look at these guys and see. Oh yeah. Oh, that's interesting. That had to be okay. So hold on.
Or maybe not. Actually, this guy's got some.
Getting a bit of scatter there. Oh, not much. Oh.
They're all the same?
One random.
One random.
They all get the same one random. See, like all of them they got the same value.
Yeah. Yep.
So
what do we have to do to fix that? Check out the iteration.
That's actually a bit of an interesting one. That that's actually kind of funny. All right. So the seed should kind of roll as you do a next float 3. So that's a little bit of a surprise, unless it was expecting me to use the previous one. It might have been actually. No, we shouldn't be doing that, surely. That's a bit mental. Next float 3. This is where I want to just scroll that side, you know?
Anyway. How many times do you actually call float 3? Are you calling it? Does it not change actually randomly? Like, is it returning?
This should be happening when it's, sorry, go back. When it's creating the, here in the star controller, when it's doing the settle position.
Okay, you're calling that 20,000 times.
Yeah. So that should have been different, not, one for the whole thing. Min and max. All right. I'm not going to lose too much sleep on this. Let's try something else. Hold on. In util this time. Do something different. I could have left it that way. Anyway, whatever. We'll do this for now. Make new float 3. With random. Next float. Just do that 3 times. If this doesn't work out, then I'll use the uni, like the old vector 3 one. So this will give me a little more information because either I'm going to end up with the same random number in X, Y, and Z, or it actually should give me random numbers for every iteration. Oh,
yeah, I'd say it looks like before you could have been using the same, the way that system works, it may have been returning the same seed value.
Yeah, actually, now just to make sure, it's kind of bizarre. I'm just going to put them as the same for a second. And do this. They should be X, Y, Z, but just for the minute. I just want to see if they come out all the same, because it tells me more about what's happening with that random. But it's not quite. The next should compute a new random number every time, but it didn't seem to be. And not still. Okay. Yeah. Okay. That's what I was thinking might have happened. All right. So I'm not going to lose sleep over this. Let's do this kind of a less interesting way. That's still running, isn't it? Stop that. Because we only need the random once, so it doesn't even have to be super performant code. Right. So we've got a few different ways of going about this. Let's try using the Unity engine random. Which I forget what it looks like, so I'm going to go back over here. Yes. Down here, classes, near the bottom. Actually, while we have this up, there's a bunch of new job system related things for physics that they've introduced, or after random, which is actually quite handy. So for instance, there's now a Raycast command, which will issue, this is for jobs, it'll actually schedule a job system job to do a Raycast. And they've got
that's
a
cool.
Boxcast. Yeah.
Wow.
So
nice,
you can
and
actually
get your hit results back that way. Wow, that's got to be crazy performant. No longer have to do raycasting on the core thread. Wow, that's cool.
Yeah. So now range. Random range. Yeah, okay, that's the guy we kind of want.
So it says the range. Let's see.
Range. Yeah.
Sorry, guys, I'm reading your chat here.
I need to instantiate random.
You can do probably If you want to do, yeah, I mean, I think for the random pose, right, you want it to be a large number. So just your unit engine random.range.
Yeah. Random. Yep.
Yep.
That's a marker. 0 to x. Okay. Get out of the way. I love your Visual Studio, but you have times where you get in the way. Okay, this should be better.
Let's see. So I think this is going to have our cube spawn in the center to the right, though. So we might want to do negative max, too. Let's see.
That's true.
All right, yep.
Okay.
Cool.
It's a mess of cubes. All right. Well, we can move the camera later or whatever. There's ways and means.
Or here, just use that. Instead of 0, just do negative max x, negative max y.
Yeah, okay. Which is kind of close. It spreads them all over now.
Yeah.
So I like making one change, testing it, then move on, knowing that I've got that, that foundation, that the last change worked. Okay, cool. Right, so they're not moving yet. We'll update their position now. But at least they're sort of spread out, and there's a bunch of them. It is interesting to see that actually the render is doing pretty well. So I have seen this actually with 20,000 objects. You can get around, in the ballpark of 200 FPS, just with 20,000 objects.
So hold on, can you click on your main camera though? I was just curious, how many do we have in view of this thing? Okay, you want to try like zoom in out a bit?
Yeah, let me just bring this right here. There we go. Let me do this so we can actually sort of see what's going on. So they should all be kind of in front of. Oh no, okay, let's bring that back a bit. Wrong way, all the way through the other side. Okay, so now we're down 70. Yeah, that's more like it.
Wow, you're still even now. I mean, what are you on? I don't even think I was getting that good of a frame. I was getting like 30, and they weren't even. Although I don't remember what we were getting before we started moving them. We may have been around the same actually. Because so far we haven't done anything other than we processed on the thread on multi-threading, just our initial positions, right?
Yeah. Yeah. So this is. I know what you mean. Yeah, I think I saw that in your video actually. It was around 30. So I've got a Ryzen 9 3900X.
Okay.
So I've got a large number of threads. I've got a rubbish video card though. It's only a GTX 770. But the thing is the CPU, so if we look at this, and this is what's cool about the profiler, it gives us a pretty good handle on what sort of performance you need to get what sort of frame rate. So the rendering, if I turn this off and on, you can see that's the rendering time. So the rendering is taking up most of the time here.
Right.
And so, there's only so much. Well, there are things we can do about that, but right now that's where the lion's share of the work is going. All right, let's move these objects and see stuff happen. So that is where there's a bit of a challenge that, different rendering is going to give you different performance, which of course why video games have different settings, right? Like max settings and versus, min settings and that sort of thing for different resolutions. And then the resolution's another factor. Right, so now what we want to do is in the update loop, having computed a new position for everything, we're going to basically update the position. So down here, void update transforms. Oh, not what I had in mind. Got too smart for myself. Okay, so this is where I'm going to need another array. Private. This will be our transforms. I'm not going to be very original on that one. Okay, bang. Down here when we allocate, so allocate transforms. Put this number of objects, setting all the positions, that's fine. Down here, this is why we need to keep the game object. So forms index equals game object dot get component. Now I could do just this, but I hate doing that. Well, I hate doing that in general. It actually turns out to be the same code as doing this.
Right.
And the trap is that when you use that property, it's actually a property method. If you use it in update, like there's a temptation to use that thinking that that's like some solid reference you have, but every time it's always doing this get component. So I just write it off. It's in my blacklist, right? I just don't use it. Okay, so that's set up our transforms. So we should be good to go. So in here now, less than transforms, dot length. Transforms index. Now we're just going to take the position and we're going to make that equal to the position X. Now, the funny thing here is that's really in vector 3. This is really float 3, but Unity has like casting, automatic casting in place.
Okay, very cool.
Yeah,
I'm pretty sure when I was experimenting with that, I don't think they had that time. Maybe they've updated that.
Yeah, it's something. Now, what we can do before I lock the memory, I can do the move here. So update transforms. So this is the idea is that based on the previously computed positions, let's move everything, and then now let's schedule a job. This may actually still conflict now that I think about it, but no. This will happen synchronously, then this will be scheduled. So this should be fine. There should be no competition. Now, what we're going to see here is the performance of this code running directly.
Right, now that code is running on the main thread, right?
Yeah, exactly. So then we might have to move this out into a separate job.
Okay, yeah.
The trick with optimization is don't optimize more than you need to, right? So, if this was enough for the performance we were targeting, why do any more? Right, why make the code any harder to maintain? Okay, so these guys should be moving now. Yep, there they go. And I'm getting about 40 FPS. Now, if we look at here we go in the profiler. This orange kind of baby poo brown part of the graph is physics. So if I click off the physics part, we can see that it's definitely physics, right? So in the legend here, I like to click it off and on. So physics is taking a massive chunk of time. So this is where we can look at our first set of optimizations that we can do. So if we look at our prefab here, why is physics even involved? If we get rid of the box
you got cubes hitting each other. Yeah, okay.
Yeah. Well, even if they weren't, it's going to do that check just because we've got a collider. It's got to do that check. So we get rid of that and we see what the performance is like. 65 frames per second. So, 87. Yeah, actually there's a little blip. Initially, it takes a while for it to settle in. So we've practically doubled the frame rate. It's gone from 40 to about 80, give or take, just by getting rid of the collider. So this becomes one of the trade-offs, right? Like as we go through this stuff, there's a series of trade-offs that you have to make. It's actually just dipped. It's gone down to 70, but it's still a lot better than 40. So there's trade-offs that you have to make as you go through optimize. Oh, I know why. It's because more of them have moved into the camera view, so the performance will start to drop. But the point is that you end up having to make trade-offs. Yeah, they're all now in front of the camera. So it just means that the rendering, so again, if we go to the profiler, we'll see that so now the physics has dropped. So this is from the previous run. This is the new run. Physics is gone completely. We've eliminated that as a problem, a challenge to our performance. if we look at the player loop, we can see what is now taking up most of the time. So first of all, we can see that our update call is taking hardly anything at all. The render is probably, let me go back to scripts, right? So scripts, if I turn scripts off, actually there is a good chunk of time which will be our update. Let's find that. It'll be our update update transforms. I said I couldn't do and think at the same time, didn't I? Where are you? It'll probably be in the other player lab. Usually there's two. Hang on, let me collapse this. Oh, no, just one. Okay. Unity have changed the structure. So I remember in 2014 it was toward the end of, when I got involved, the end of Unity 4.5 or something. And then they had version 5 after that. And at that point, you only had one player loop. But things as they've introduced the job system, more and more of Unity engine is actually happening as jobs. So even if you don't explicitly use jobs, you're kind of using it anyway.
Huh.
Scriptable runtime, no.
Carrie asked, are you using a hybrid renderer? I don't think so.
No, I'm not. The hybrid renderer is more for ECS.
Yeah.
Yeah. And that actually, if you involve that, because that's still experimental, then you end up getting an experimental version of the burst compiler, and like you get all these funny updates.
So with this current job that you're doing, can you go back to the job? So you're using just a traditional job. It's not a it's an asynchronous job. It's not multi-threaded. Right?
Yeah, exactly.
Huh.
So what's cool about this is it's literally, it's able to run this in the background. And the reason why it has such a little impact on the main loop is basically it's doing its work in the background. Whenever it's going to be ready, it could be 5 frames later.
Right.
Then we're going to basically pick up on that. Okay, you've finished computation. I'll now update the transforms. So what I've done is I've literally decoupled the computation of the positions from when I'm going to push that into the actual scene, when I update the scene graph.
Interesting. So now that system there, we kind of like, and that like kind of reminds me of the Unite talk I watched, where the guy was like, you should do it for one specific task at a time.
Yes.
So if you wanted to move it as well through the job system, that would be a whole separate job. Is that right?
Exactly. And in fact, we're about to do that. So if we look here, we can see that my current update call is taking 10% of the time, right? Which is that blue bit that's highlighted now.
It's probably that iteration of 20,000 cycles.
Exactly. That's exactly what it is.
Yeah.
Now it's taking 4 milliseconds, which is, it's chunky. If we could get the render time down, we can't really, but if we could, there's probably, I've still got one trick left to trying to optimize the render time, but it's not going to do that much.
Well, and that's the shadows, right? Like, what if you turn off shadows?
Well, there's shadows, and also I don't even have GPU instancing set.
Oh, okay, gotcha. Yeah, so the materials aren't even being.
Actually, there's a couple of tricks. Yeah, so there's a few tricks in the materials to improve the rendering performance. But if we could nullify this, then this would be fast enough, right? 4 milliseconds is like well under 60 FPS. Sorry, it'll be more, way more, right? So you need 16 milliseconds for 60 FPS. So if you had 8, you're like in the 120 FPS territory. Right. So 4, if that was all that was the getting in the way, we'd be laughing. But yeah, there's more to it. So because this is in our control, we definitely should move it. So we'll do that now. All right, so we're going to make another job. Job. So this will be the update transform job. We go through and get rid of a whole heap of rubbish.
So in this job, what are you going to, is this going to be a parallel 4 or is this going to be just a job as well?
This will be the transform parallel 4.
Oh, okay, very cool. Okay, cool, because we're moving transforms.
That's right. And the reason why it can be a parallel 4 is because it's only going to read the positions array. It's not going to try to change it. So Now we actually have a data pipeline.
Gotcha.
So this is like as you were mentioning before from the Unite presentation. If you do one thing at a time, you end up actually creating like a data pipeline. The multi-threading, not only multi-threading, actually, modern CPUs are really designed for this.
That's awesome.
If you can cascade things going from one to the next to the next to the next, that's where you get efficiencies. That's how GPUs are built too. Unity.jobs. Actually, am I going to need that? I may not need that. I do want collections though. And I want Unity engine jobs. It's the namespaces where jobs appear is a bit of a scattered mess, but there's a reason for it, but it is a bit of a pain. We'll also want burst using the back to that. So now in our structure, we want our transforms access array. Actually, no, we don't want that at all. Yes, we do.
No, you do. Yeah, you want that. Yeah, transform access array. Yeah.
Because remember, this actually gets passed in, but the transform access gets passed in the loop, but the arrays, because I'm going to make my begin method here. That's what I need it for.
Gotcha. Yeah.
Actually, I'm just
going to do it that way. If you're going to do it with your begin way.
Let's do this. Job handle. Begin. I want that there. That's where I want that, now that I think about it. Let me finish this thought off, which is it's an I job now, parallel trans one. Okay. And complete that. So I need to provide this in order to set this up in the scheduling. So
right, you provide it, but you need to map it then to the... You also still need the variable, right? You still need the field in the job itself.
Honestly, I forget, so I'm going to go back over here and find out. This guy. In the schedule, actually the interfaces will tell me. Maybe they will. No, they don't. Thank you. Back here.
Because you're going to pass it in as a constructor, but if you don't assign it to anything in there, you won't be able to grab it.
Yeah, it's the schedule. Yeah, this is what I thought. So in the schedule, we have to provide it here.
Yeah.
But then in that magic for loop that's running in the when it's casting out, creating all these threads with or using all the jobs with as the for loop, it will actually.
Oh, okay, it already has it. Okay, interesting.
Yeah.
Ah.
So that's why that's here. You see.
Yep.
So the only thing I need to provide here actually is the positions.
Interesting. That's cool.
Yeah, it actually sort of ends up being quite now. Mathematics is useful.
When you use multi-threading in Unity, does it slow down everything else like streaming or screen recording? I don't believe so.
They'll use different threads. The operating system will schedule in a nice way.
Right, it would factor around the application you're currently running.
Yeah, exactly. I mean, that's the other thing. Unity's pretty conservative about how many jobs they create as background threads. But you can, in my own experience with multi-threading, you could, for the number of cores or even the number of CPU threads that are available in a machine, you could actually double that and still get some useful work out of it. It won't scale 2 times, but you'll get like 1.5 or 1.3. So if you've got a dual core machine that has multi-threading, then you'll end up with 4 cores, CPU cores. Dual core, so you'll end up with quad threads. You could create 8 operating system threads, native threads in C# and get useful work, useful parallelism. Okie dokie. So positions equals, okay, I need to pass that in. Float, I'm typing with an accent. we can do a return job transform parallel for extensions, schedule job with our trans array. There is actually one other thing we need to provide. Yeah, that's it. Okay. Well, the one other thing, let's pass that in. So, because now I'm creating that pipeline, and I'm going to move in one job, I'm going to do the moving, and in the next job, I'm going to update the.
Oh, right. You need to make a dependency, right?
I have a dependency.
Very cool. That's awesome. So you're going to pass into the scheduling of this the other job.
Exactly.
Very cool. So that job has to finish before you can process this job.
Exactly.
Very cool.
It's a nice way of coupling them together, right? So now I have this thing that will update their positions, and I've got this other thing that'll wait really nicely. It'll wait until the other ones are done, and then it'll scoot off and in a parallel way update their transforms.
Awesome.
This becomes super easy. So it's now just transform position equals positions index. That's it.
Oh, very cool. So now, hold on. Do you want to plus equal them, or do you want to teleport them to those positions?
I want to teleport them. Their position has been fully computed in the previous job. So we go.
Cool. Let's see.
So here, because this is the position I want, because we've done it. We've taken their previous position and added delta time.
Oh, okay. Yeah. All right. Very cool. Let's see how this looks.
Yeah. So then over here, all we have to do is set it. So all we're looking for here is that efficiency in the way we update the transform. That's all we're after. Now, I do want to use the burst compiler, so we will do that. And now we're done. What I have to do, though, is I have to create my transform access array back over here on the star controller. So that'll be the new thing to worry about. So over here, private. Do I still have that? I do. Nice. Yes. Here.
Unique engine.jobs, yeah.
Right, exactly. And now, back in our allocate. On array. Actually, there's a few things we can do here. Anyway.
New transform access, yeah.
Let's have a look. We've got a few interesting variants. We can either do it by the capacity and then set the values in, or we can provide the previous thing. I have a feeling that it has to take if we use this constructor. I don't think, because we actually haven't set the values here.
Right, exactly. It will get populated. Right, you probably want to do it by your index.
Yeah.
Because it hasn't been populated just yet, so it's going to be null.
Yet. So that's actually what we'll do is we'll do it by the capacity, so number of objects. And it's going to ask me how I want to allocate this, or it should do that. Should be the next question. Right. No? It normally does.
It looks like just that. I don't know what the desired job count does.
Oh, actually, that's like the number of threads you want.
Oh, okay.
Now, it won't guarantee that you'll have that number of threads, but it's kind of like, give me a wish list on how many threads you want for the parallel 4 to be scattered across. So it's funny how the transform one works different from the jobs, sort of the unity.jobs iParallel 4 interface works. So for instance, if we look at the transform access array, if we look at the constructor, again, documentation, but desired job count, basically how many jobs do you want to scatter it across? Now, actually on this, I think there's also, allocate desired job count capacity. No, that's fine. It's the same either way. I thought there'd be the allocator like you have on native thingy, but they don't have it, so that's fine. Whatever. what we want. So in many ways, this does perform like a native array. So internally, it's kind of like a native array.
Right, right.
Now, the funny thing is we won't need this one anymore.
Right, because now you're moving the movement to the job system away from monobehavior.
Exactly. So down here, I still need to get the but now I want to do transform array dot add.
Yeah.
Basically.
So now you're basically populating this native array with 20,000 stars.
Yeah. So it's this sort of it's like a native array. This transform array is going to get this. It's like a native transform array. We'll have all of these transform references, so that we can then use that in our job. So I will clean this up. I will allocate in the undestroy. Actually, I wasn't doing that anyway. All right, so in here, we have our transform array dot dispose. That has to be disposed to.
Yep. And
this is going to get a bit more complex. So up here, because we're dealing with two jobs, I need a job handle transform job. Now it gets interesting. I can check that both of them are done. Not what I wanted. Transform job. Complete. And then I have to complete them both. So this becomes a bit different. Job handle dot complete all.
Yep. And then you can delete line 43, right?
Exactly. Job, and then the transform job. So that makes sure that they're both unlocked.
Gotcha.
Basically. And then job equals, like Daniel told us before, like don't forget to do that. Transform this one, update transform job dot begin. I have to give it the transform array, the positions, and the move.
Right.
This is our
So
chaining.
it relies on that one. Very cool. So moment of truth of having these things move and getting that insane frame rate is about to happen.
Exactly. Now remember, it was only taking 10%, so that 10% should collapse to
right,
like
0.1% essentially.
Yeah.
Very cool.
Now,
let's see.
This is missing one last thing here. So actually I can copy the same complete all. Pop that here.
I mean, that would be 100. That would be 100x increase if it did that. We'll see. I think maybe 1%. Let's see. That'd be so cool.
I already had that. What am I doing? Okay. All right, we should be good to go.
Yeah, the move star job is still just an I job. Basically, the I job is going to run in parallel to the main thread, just updating positions, and then his transform job is waiting for that to complete before it updates its new positions.
Yep, I had a feeling that I missed something.
So this is something that's interesting now. Even though you got some errors, the frame rate is still high, so it's still executing, right? Like I noticed this too when we were running into some issues with I don't know what these errors are related to. This is this is saying that your update transforms is null.
Yeah, so because it's getting an exception in update, I think the update would have stopped working.
Yep.
So that was line 61, right? Yeah, line 61. Moaning about this.
We don't need any of this anymore, right?
No, that's right.
Comment that out, yeah.
Oh, okay. I didn't. There you go. I knew I forgot to. I should have got rid of that. Then the compiler would have moaned at me correctly. There we go, like this.
Yep. There we go. Alrighty, moment of truth, everyone. This is what everyone's been waiting for. Here we go.
Exactly. Okay, clear up that mess. Let's have a look. 77, 128, 127. Now that's a lot of objects yet to get in the way of the camera.
Right.
But it's pretty smooth. And if we bring up, well, let's see, we can move the camera around too.
So 100 plus frame rate's pretty good. And yeah, what happens if you move the camera view back? Let's get more in view. And then open your profiler. Let's see what the performance change is on that.
I'll move that here and then I'll move it across. So we definitely
that's pretty damn good right now. 80 frames with, wow.
So that's pretty happy. So let's now do it. Control 7. Yeah, look at that difference. Okay, so that was before. This is after.
So right. So we saw this too, but for some reason we were still getting like 30 frames. So it's interesting when you break it up like this. Because what is your processing time on that? That's 0.52. So that's literally a 50x increase in speed of processing time.
It's actually like the whole update loop is 1.6 now, whereas before it was about 10.
Okay. So we're getting like a 9. Okay, so like an 8x speed increase here.
Yeah. And if we look at, pull this apart a bit, behavior, star controller, so that guy's taking that 2%. Oh, look at this. Mm-hmm. And it's spending that time waiting for a thread. Right? So that will be that one.
Very cool. Now, what happens if you were to remove the move job into a parallel 4 and we broke up that 20,000 into chunks?
So that should actually improve a bit. Where it's going to improve though will be not in the player loop specifically. Oh yeah, not in the main thread. I have to find, it'll be all these workers, right? So.
Oh well, yeah, look at that. That's cool.
Yeah.
Also, yeah. Someone just mentioned too about the lighting and the shadows and GPU instancing. You might be able to double your frame rate.
Yeah, exactly. That's exactly right. So we can give that a crack next, actually. But yeah, if we change the iParallel 4, the problem, which workers getting the job of, the iJob is a bit of a guess. As you can see, I've got 22 to guess with. So here is a burst, cull. So you can see in the jobs, they're doing a lot of, I don't know how easy it is to read this text actually. I don't know if I can sort of zoom in, but basically in this one job worker number 22, it's doing, what is it? There's a few extract, render, node queue, render loops, sorts. There's all sorts of player architecture work going on. Update transform. There it is. It's actually there. No, that's the transforms. That's one of the transform jobs that would be scattered across. So I'm looking for the move. This could take a while. So if I don't find it too quickly,
I just realized too. Are you using the burst compiler over your new transform job?
Should be. Yep.
Okay, yeah, okay, good deal.
Not seeing it there. All right, this is, I'm not going to worry about it too much, but I was just, if we could find it, I was going to show what kind of, I'm not being super methodical here. If we could find the move, right? So I was thinking of this move star job because it's a, just an iJob instead of an iJob parallel 4. Right. Just to ask the question, well, how much does it actually take? The thing is, it actually doesn't matter. Even if it took 5 frames for that to finish,
right? It's
because it's decoupled from the actual frame update. What would actually happen is if it took too long, we should see the frames, the way the blocks move should get a bit jerky because they should sort of jump. Like if it was, say, 10 frames or 5, maybe even more, say 5 or up frames per second. Say if it took 5 frames for that to complete because it was an iJob instead of an iJob parallel 4, it would mean that, that update, 5 frames would go by and they'd be completely still. And then all of a sudden 5 frames worth of delta time would get added to them, right? So they'd kind of just jump, and then it'd be another 5 frames and then jump, right? So that should look really sort of staccato kind of thing, but we can see here that we're not doing that.
So in theory then, using an iJob Parallel 4, just because you spread across 20,000, are you saying that even if you spread across the 20,000, the 20,000 processes, it wouldn't actually speed up anything, essentially?
It probably won't. Yeah, it'll be a small uplift, but it won't be much.
Okay, gotcha.
It's probably not worth chasing. Like, in order to do it,
because it's like 5 frames, so the naked eye can't even see that.
Yeah, exactly. Well, I think it's actually less than 5 frames, just based on how smooth this is. Like, if I undo see how smooth. I mean, the funny thing is, this is being rendered in 2 cameras actually, when you think about it. But that's, in fact, let's stop it and let's put it on max.
Yeah,
right?
Let's see.
But that's pretty smooth.
Yeah, I mean, 120 frame rate. I mean, it's a lot of objects.
Yeah.
That's pretty
And you
good.
can see the batches, you get 10,000 batches. So it hasn't hit, like, they're not all in the camera yet. You can see as this climbs, the FPS will drop. That's your trade-off, is the batches it's the rendering hit it takes. But it's still pretty smooth. And that means that the frames, the iJob is not taking too long. Like, it's probably 1 or 2 frames.
Right. So so at that point there, it's like it's not really worth it. I mean, because it's showing to be pretty smooth. That's awesome. So how do you feel about doing some Q&A?
Yeah, sure.
Yeah. All right. So I think the first one that's really popular is I'm gonna go through everyone's Q&A here. So if you have any questions, guys, add them to the Q&A. I see all the questions. You guys don't. I'll publish them as I go through them. The first one is, when should I be using? Everyone who's watching this, we all want to make mobile games, or we want to make a game. We don't have a scenario of 20,000 cubes needed. If I have just, hey, I'm just checking, I'm creating a space shooter game, and when I hit the space key, lasers are firing out. Should those be operating on separate threads?
Okay, so a little bit like my previous comment, don't optimize when you don't need to. So you could prototype it with game objects, and you could see, how well it performs. And if you're thinking there's going to be 30 objects on the scene at once, like particularly if, say, it's a 2D game, like Asteroids or something, right? And you only have a few asteroids on the screen at once, then it's never going to be an issue. So you may as well keep things simple and just have game objects completely.
So when would you say? So what is like a key identifying point to use the C# job system?
So so for instance, you could use it for some interesting computation in the background, like going back to the asteroids one. Even though you might have, say, 30 objects on the screen at once, you might be wanting to randomly and procedurally create your asteroids, right? The mesh.
Right.
And if you were doing that, then you could create those suckers in a job. Okay,
calculate all the vertices and things like that, and then they can appear on screen once that job is finished creating them.
Yeah.
Okay, interesting. Let me see here. Quentin asks, yes, this will be recorded, guys, and you will get the links to this. Also, the link to the Github project that Warwick put together, you'll get access to.
Yeah. I should probably show that just quickly as well, so they know what we're talking about, because it's a little different from this, of course.
Yeah, feel free to go and pull that up. And then while you're pulling that up, Brian asked, the job system requires structs versus classes, right? Yes.
Yeah.
The C# job system is purely struct driven, and it's the backbone of ECS.
Exactly.
So everything is value types now. Let me see here. Let me see. Where can we watch the previous webinar? For the previous recordings, you'll find those on gamedevhq.com in the vault. Let's see. There are some systems that Unity is releasing now that rely heavily on the job system, like animation rigging. Do you have any experience and/or suggestions for organizing threading with Runtime Ik?
Oof. Okay, so that's not something I've played with myself, but it makes a lot of sense to do that with background threads. I mean, Ik can be a pretty, the modeling IK is a bit lumpy, right, as a process in terms of the maths behind it. So it makes a lot of sense for that to be done in the job system.
Okay, cool. Cecilia asks, what is Lerp? Lerp is linear interpretation, so going from one point to another point over time. When it comes to coding for C#, are there multiple ways to do it, or is there just one way?
For jobs? I assume that's for jobs.
I assume so.
Yeah, so for the job system, well, okay, so what could you do differently? You don't have to do the begin method like I was doing, but you need structs. The way they've structured the jobs themselves is kind of a thing about Unity. If we look at,
and I believe the rule is yes, the C# jobs have a flow of how you should be using these, like schedule early, make sure they complete before running the next ones.
Exactly. I mean, their structure is very specific, and it's because they're trying to make it simple, right? They're trying to hide the whole, creation of a thread and thread pooling and mutexes and all
right. This is all just like a massive wrapper class, right? Against threading. Exactly. So it's and this leads to the next question. Rajesh says they just started learning C# programming. So my question is, should I ditch C# and start learning the C# job system? It's important to know that they are one and the same. The C# job system is just a extension of Unity on how to write safe, performant, multi-threaded code.
Exactly.
Okay, very cool. So this is the GitHub project that you guys are going to receive.
Actually, sorry, my bad. This is this is the other example that I did.
Oh, very cool. How many objects you got flying off there?
So this should be, it's 40,000.
40,000, nice.
I made them variables, the batch count and the transform, so that number of threads for the iJob transform. So I could experiment with this, and I found that 10 actually was the optimal number for me. It could differ a bit with a different number of, say, cores or CPU cores, basically. If I went either side of 10, it started to dip, but only by a few frames. It wasn't massive.
Huh, interesting.
But what was interesting, so here it's like 33 FPS, and that's because the position of the camera is murder, as in it's kind of right above what looks like a bit of a hurricane.
Right.
If I move this in any direction, the camera, it changes the performance.
I can imagine. Right, you're getting every angle, light estimate calculation in there. It's
it's exactly, like if I pull this in a bit, you can see it's already up to 72 FPS, like it's almost doubled just by
changing the angle. Wow, that's amazing.
Yeah.
Wow. Okay, so there you go, guys. This is 40,000 red balls spinning around here.
Exactly.
Very cool. So
there's the other example, actually, if I just quickly pull this up. I have to go and come here, Unity Hub.
While you pull that up, I'm just going to go through another question here. What's the easiest way to convert all map objects like trees, rocks into entities? That is definitely an ECS question for another workshop, possibly. Yeah. Let's see. As the dots packages have been updated, how difficult has it been to rewrite ECS job code after breaking changes and updates?
Well, okay, so with ECS itself, that has changed a fair bit over time, which is kind of why I've left it on, like for my own projects, I won't use the ECS yet, but the job system is stable.
Yeah, and that's an important thing that I talked with Warwick about, is that's why I'm comfortable using the C# job system with you guys, is because it's finally a part of, it's the backbone of ECS, but it doesn't require ECS to use it, and it's insanely good. So as a C# developer, your skill set as an object-oriented programmer, you're not breaking that design pattern by using the job system.
Exactly. Actually, I'll quickly do this from scratch. Oops, I just gave it no name. Never mind. So I'll just plop in the code as it is off GitHub so people can see how that's sort of set up.
Cool. Lucas asked what packages are required to use everything dots?
Okay, so there's two everything dots there, and there's whether you just want the job system or do you want jobs plus ECS.
So go for job system.
Just job system. All you need to do is add the burst compiler. The burst compiler depends on unity.mathematics, so it'll pull it in as well.
Okay.
So you just add that one thing. So in fact, we'll do this right now. I'll do a setup because I'll create so this will use the GitHub project. So let's make a new scene. Great. Okay, demo. We'll open it. I'll get the down here. I've got my where are you? Where am I? I'm in the wrong spot. Now here. This one. So it's the Always Move demo. If I bring up the project for half a second. Yep. So this is the project, but you'll get the link later on. So this is basically the project. It's a reasonably simple example. And if I copy this into my new, it'll be called New Unity Project because I was so smart and forgot to name it. Paste that into there. Unity. That's fine. Get all cranky. It's actually getting cranky because I haven't loaded the packages. So to answer that question,
you just go for burst.
Exactly.
Awesome. And that gives you everything you need for and that's basically just the burst compiler and the math library.
Yeah, exactly.
That's the only thing you need. The C# job system is built into Unity as of, I think, 2018.x.
Yeah, exactly. Because they've started using it in their architecture.
That's awesome.
It's funny. It's funny, actually, even in the scriptable render pipeline, that started before the job system was baked in. Mm-hmm. And they've changed the way the player loop works. Right, the player loop actually spreads in a way that's difficult to predict, but it actually spreads the work in I don't know whether it's across two jobs or, so the main thread is already starting to get broken up.
Very cool.
In Unity. So it's kind of interesting. So now, what's cool about this actually is this. Oh yeah, let me spread this out a bit so we can see.
So real quickly, Ben asked, can you see these techniques being useful while creating professional 3D applications like LiDAR, photogrammetry, or simulation programs?
Yeah. So as you were getting input, say, from the LiDAR, something like that, that's where, depending on how you interface with that hardware, certainly using this for a background thread, even if it were, sometimes you have to use some native code, and that may not be compatible with the job system because the job system's got some very specific dependencies, like don't use reference types, right? Like you pretty much need to use mostly value types. Particularly in the native array, you should be using value types. They have to be blittable is the fundamental thing. So if your hardware interface required classes, that would be a bit tough. But what you could do is you could maybe break it up. Any computation, any work on actually processing that data, that could be done as a job, and then you might have to just do something else for the integration part, getting the data out of the hardware.
Very cool. And then just confirmation from Lucas: is multi-threading done automatically? Do you have to do anything else other than separating each job manually?
It's done for you.
It's done for you. That's everything, all cleanup, all race conditions. There's no chance of error with the C# job system.
That didn't work for me.
Supposedly.
Yeah, basically.
Is the ECS and job system only meant for visuals, or can it be used to manage data behind the scenes? You could do, I imagine job system is just for processing, right? I mean, we showed that here, that it was processing insanely fast.
Yeah, exactly.
So yeah, I'd say, and you're probably encouraged, I imagine, to process, but then you can get into the whole subject of over optimization, but I'd say it's definitely possible.
Yeah, no, it's until they make more of the Unity player available for jobs, like we were talking before about that Raycast or Boxcast, because that now functions as a job. You could do a pipeline of things, so it makes it more and more possible. I'm finding it difficult to find this thing, so I'm just going to give it the ad.
Brian asked, can you explain what the allocator is used for and if there are different kinds of allocators?
There are different types of allocators. So the allocator is basically telling, like for the native array or those native containers, how you want that memory to be allocated. So they basically have a few different types. If we go to here, they have, I'll just jump here.
Yeah, I think there's like persistent, which is for the life of the program.
And there's temp, but I've found that persistent is the one I would go for every single time.
Okay, interesting.
Actually, it's not there, is it? I'm in the wrong spot, not collections. Collections, it'll be an enum allocator. So you got invalid, which is what it defaults to. There's none, don't know why you'd use that. Temp job, persistent, and audio kernel. That's clearly somewhat specialized.
Yeah.
So persistent's the one I go for. I've tried both of these, and the reason why I wouldn't go with them, even like the code, because the memory is allocated and then it's going to be destroyed very quickly after that. You have to sort of unlock quite. So the point is, you'd have your game loop, right? And so you would allocate your memory, like you would allocate the memory using, say, temp. You'd populate it. You submit a job. The job is going to run, okay, in another thread. But if you do a complete on that job handle, then your main loop ends up waiting for that thread to complete. What's the point, right? So instead of, all you've done is shifted where the code runs, but the time will still be the same in the main loop because it's got to wait for the other guy to finish. So that's why I don't use temp and I don't use temp job. I always use persistent, and then I can set up that pipeline of data flow.
Very cool. How much of this is Unity specific, or how much can be used in regular C#? So everything you saw today is just pure C#. The only thing is that we're working with, there's no difference. All we're doing is working with different libraries and different APIs. The C# we wrote today is the C# that works on .NET, the web, whatever you want to create. The job system is just another library, just like AR Foundation is a library, right? And the AI simulation libraries. The code we wrote today is just C#. We're just working with libraries that are a part of Unity, different libraries. Let's see.
Nice demo. So I'm setting up my controller.
What kind of, this is a good question. What kind of compatibility concerns are there with traditional mono behavior workflows? How much work is needed to get jobs to work with game objects and scriptable objects? Ooh, that's actually good. Do jobs work with scriptable objects?
Actually, so that's something I haven't tried, but I don't see a reason why they wouldn't.
Right, it just reads the data container same way, I imagine. You pass in the data into the job from the mono behavior, I'd assume.
What you might have to do, though, a bit like what I've done here, where is it? So when you have a scriptable object, you have usually we'd have a class, right? It's a very similar to a mono behavior in its structure. It's a scriptable object, but it's the parent size params here. This is what I'm after. So this size params is a struct, but because I want this to be accessible from the Unity editor as values I can edit and see how I've got tooltips on them and everything, I had to make this serializable. So because this is serializable, so you could do the same thing in the scriptable object. You can have a struct, make it serializable, and then those values, because this is a struct, that can be passed into the job, right? So the point is the scriptable object can contain an instance of this struct, and then you can manipulate it in the editor, just like anything else. And then you can take that serializable, that value type, and you can pass it to a job.
Yeah, pass it to the job, yeah. Very cool. Would you say that the job system would be recommended for multiplayer games?
Yeah.
Yeah.
Especially if you're doing any. Now the network code, I think Unity is still working on a new version of the network code.
I think they are creating an ECS networking solution. I think.
Yeah, I believe so. Yeah, I know they've got something
networking, something like that.
The previous network code is back from about Unity 5 point something days, which I can't remember which, but that wouldn't have job system type stuff in it.
What he was in the job system, when you compile, what does the compile synchronous parameter mean?
Okay, so let's find it in Unity's words, but basically Nope, that's not it. Okay, so what it's doing, burst, here we go. They can do it asynchronously or synchronously. So it's about when the burst compiler kicks in and does the compilation. So it's like you have ahead of time compilation or just in time compilation. The asynchronous one would be just in time, and possibly other things can happen in the background, but it's very just in time.
Okay, so would you say rule of thumb when like just always use asynchronously?
I think it should lead to at least some simplicity. Yeah.
Yeah. Okay.
Execution.
If we are saving all the time using bursts with the positions, why would we use a regular for loop? Okay, that was sad. He was demonstrating that. That was a bad question. Let's see. If using bursts is significantly faster, hang on. Okay, here we go. So if using burst is significantly faster due to parallel instruction, does it have overhead elsewhere, like in a compile time or file size or RAM allocation?
If it's doing it just in time, that can impact, like that has to be allocated somewhere. So that might be happening on the heap, and in which case that could have a little blip in terms of performance,
Okay.
Which is why you do it synchronously. So when you actually do a build, it actually becomes, it should all be AOT. It's all ahead of time, especially if you're using IL to CPP. So on Windows, or actually most of the platforms now, they support that conversion of the .NET IL code into C++, and then they compile that to native. And so the burst compiler optimizes that whole process of transforming the IL code into optimal native instructions. And you can actually see that from the jobs, the inspector. Here we go. So you can actually see they've got assembly IL. So this would be what the normal IL looks like. Then they've got this, they're using the LLVM. That's a compiler framework.
Right. That's where the insane performance is coming from. Is this guy right here?
Yeah. So it's how they've. This would involve strategies for unrolling loops and all kinds of performance at the machine code level. So that's basically how it's happening.
That's awesome.
So there's a fair bit to wrap your head around here if you really want to understand what's going on. But yeah,
that's cool.
I mean, this is like at the pretty much at the CPU level. Basically, actually, I just wonder if that's native assembly. It doesn't look like x86, but it's pretty good.
Let's see. Greg says, can you specify the max number of threads it can use with the job system to ensure that Unity doesn't lock all available threads? I imagine it intelligently reserves if it detects other things running, it's not going to touch their threads.
You actually, the cool thing is you don't have to. You have no control over how many threads Unity creates. So all you do is you can ask, like with the transform access array, you can say, the desired batch or whatever size it was, you can say 10, like I was saying. But if it's only a quad core system that doesn't do SMT, all right, there's only 4 cores, and Unity will give you around 4. It'll be a little bit more, but maybe 2 or 3 worker jobs, and it'll reserve the jobs for itself for rendering.
Okay. Do you think there's ever a reason? Michael asks, is there any time the burst compiler isn't beneficial?
Well, okay. So if you look at the package manager, so the burst compiler, they actually tell you which one was up here verified, right? So this version is verified for 2019.4. There'll be other versions if we do see all versions. Now I can't see anything more recent than that unless I go advanced.
But it doesn't look like it. Based on that description right there, you want to be using LLVM.
Oh yeah, no, yeah, exactly. No, you want burst. You want the burst that's correct, verified for your version if you don't want to have any experimental stuff. But then you can see here when I go to advanced and say show preview packages, you can see they've got newer versions coming. So if you enable ECS through the same mechanism, then it's going to pull in one of these more recent versions of the.
Gotcha. And you might run into some weird issues.
exactly. It's not considered production ready. Actually, okay, that was taking forever to load some information. Yeah, you could look at the change log and that'll tell you what they're looking to do different in that particular version. But anyway, let's stop looking at that. Undo that.
Cool.
Yeah.
Naftali asked that difference between using structs and classes. So structs are value types and classes are reference types. If you guys go to the C# Survival Guide, we talk a lot about that difference in those. It comes down to structs versus classes.
And it's also the reason, this is one of the big differences between C# and Java. Java has, the only value types you have in Java are the native, the things like int, bool, float, that sort of thing. Those are the only value types Java has, and you can't make your own. And it means that, and there's actually two issues with Java.
Oh, I didn't know that. Java doesn't support structs?
Nope.
Oh, wow.
It doesn't have structs, it doesn't have delegates.
Oh, wow. That also sucks.
Oh, yeah, exactly. And Java, let's see. Java, the stack in Java is actually allocated on the heap. So that has a good and bad impact, but it means that, if you start doing something with a lot of recursion, then you can actually impact your heap, and that again can impact performance. So if you want highly performant code, then C# gives you the benefit of using value types, being able to pre-allocate an array up front, even a managed array, and just put lots of structs in that thing. And you can handle lots of state that way. And because you can allocate it up front, you're never, while you're doing any intense work, particularly in tight loops, you're not then fighting the garbage collector, and you're not locking that central lock for allocating memory.
Very cool. I'm just going through these questions here. The stack is generally a lot smaller in size than the heap. Does that limitation exist with burst?
So actually, in the OS, at the OS level, a thread will have a meg of stack.
Mm-hmm. So
now,
it has like a reserve of, there's no way you're going to load this up.
Yeah, I mean, the problem is if you work through a meg, now you could, if you had like recursion and it was unbound,
mm-hmm.
Then yeah, you could easily work through that. So yes, there are pros and cons. The trick is if you're using like your native array, then you allocate all your memory in that up front. So you use that for the heavy lifting of storage, rather than just the stack itself. The main thing about the stack, if you think about that as just for passing those values around, but really use the native array for the storage, you should be fine. But yeah, avoid the heavy recursion. Use the native array for that storage instead.
Okay, very cool. Let me see if you guys have any other last questions here. I'm just going through. I think we answered a lot of these already.
So this is the...
Dracus asked, could he use this for moving verts to deform a mesh on a collision? Yes, you could.
Yeah. Now the physics, you'll pay a bit of a penalty on the physics, but you could potentially try to recoup that using the Raycast or Boxcast collider. So you kind of make your own. You are making your own physics response anyway.
Right. It looks like they may have like job physics.
Yeah, they do. So
and you can, and you can do you can run your physics calculations on separate threads now, I guess, somehow.
Yeah, basically. So what you could do is you can, let me find it. It's buried in classes. So I haven't had a chance to try this yet, but it looks very interesting. The boxcast command, right? So this thing is, you can see here, this is basically a job. They've basically smushed together a job with some physics type of, detection, object detection within a box, right? So it's a box boundary.
Right.
You give it the extents, so the center position of the box, the extents, like how from the center, how far out is the box, the orientation and direction. I don't get that as much. Direction, sorry, orientation makes sense. Direction, anyway, that would take a bit of messing about to understand how that changes things, because a box should just be in all directions. Anyway, so the point is you get a job handle. And because you get a handle, you can actually then look at the Raycast. You get an array of Raycasts, right? Here we are, native array. So it's kind of cool because it means you can then find all the hits that you had in that box and you can process them. And so the point is that the processing of those hits could be done in another job, right? Just like we did now where we chain two jobs together. And so then how you deform the mesh could be done, you know, in a literally a mesh deformation job. And then later on you could do any transform for other things you wanted to do.
Very cool. Let me see here. I'm trying to see what other questions have come in here. Let me see here. So let's see. Would this technique also increase performance on cross-platform development? Yes, I would say this would increase performance on cross-platform. Very cool. So is this the GitHub repo that we're going to send everyone? Yeah.
GitHub repo. Yeah, exactly. So the cool thing about it. So this is using C-noise function out of the mathematics library.
Very cool.
To do a height map, right? And it's varying it over time. You can see the frame rate's 19.2. I could show you how I change. There's a few strategies we can do to uplift this insanely. So if I wanted this to be, imagine this is my floor. I've got a ship that's flying over this floor, right? So hang on, I have to right click. So what I can do, so you can see here, imagine this, go up, right? So I'm now flying and I want this effect, but I'm not happy with the frame rate. So I can definitely fix this. There's a couple of different tricks. So one is I can attack the, I can create a material. So let's just do this.
Oh yeah, do the shared instancing, right?
Yeah, exactly.
So for those who don't know, what is GPU instancing?
Okay, so it's actually to do more with the any textures, but it basically, what it does is it says this material only has to be loaded into the GPU once, and then all of the objects that have that one material can be batched together so that a single draw call could potentially capture all of the updates for that particular object or for that set of objects.
Right, it's all stored into right, exactly. So you guys, with his 40,000 game objects here, they're all sharing one material instead of having a unique material, which you guys can imagine the performance increase there.
Exactly. So if I now drag this new material onto been super creative with project name and the thingo, but let's update that. So that should now have it does, good. Now in my material, if I turn on, we would see a difference when I turn on under advanced GPU instancing. So if I hit play, I've still got that one cube in there, but anyway, it's not the end of the world.
So 19.6.
So there's actually a few things wrong with this cube. So right now we don't have the GPU instancing on, and that's okay. Now if I turn that on,